many people are terrified by the word fat because they associate fat with excess body fat and bad health. It's too bad that the fat in foods is also called fat, because not all fats are created equal. You might have heard that butter, milk, bacon, eggs, and ice creams are high in saturated fats, which are commonly found in animal products. Eating too much of them may not be good for your health. An even worse type of fat are trans fats, which are linked to heart disease. These are the bad fats you want to avoid in your diet and can be found in fried fast foods such as French fries and donuts, processed snacks such as crackers and microwave popcorn, butter substitutes such as margarines and shortenings. On the other hand, some fats are essential for our diet. Dietary fats not only supply calories, but also help absorb fat-soluble vitamins. You may be aware that monounsaturated, polyunsaturated, and omega-3 fats are considered healthy fats. They are abundant in seafood and many plant products, such as vegetable oils, extracted from olives, soybeans, and peanuts. Nuts such as almonds, pecans, and hazelnuts, sunflower seeds, flax seeds, and fruits like avocado. Plants can produce so many kinds of fats and oils which are used for more than just the eating. Shea butter, cocoa butter, and palm kernel oils are popular ingredients for lotions and creams. Fats and oils belong to the general class of compounds called lipids. Lipids are highly insoluble in water and soluble in organic solvents. Fats differ from oils in that fats are solid at room temperature, while oils are liquid at room temperature. Fats and oils, no matter from plants or animals, are actually made up of the same type of lipid molecule called triacylglycerol, or simply TAG. What is TAG? A tag looks like a creature with 3 tails. The head on the left is a glycerol, which has 3 carbon atoms. On the right, there are 3 fatty acid tails. Each fatty acid tail is attached to one of the 3 oxygen atoms of the glycerol. When a glycerol links up with 3 fatty acids, you get a tag. Here's a 3-dimensional visualization of a tag molecule. But not all tags are alike. The fatty acid tails in a tag can be the same, or there can be a mixture of different types of fatty acids. What makes fats and oils solid or liquid, healthy or unhealthy, all depends on the differences in the structures of these fatty acid tails. So let's take a close look at a fatty acid. It is made up of carbon, hydrogen, and oxygen atoms. At one end is the carboxyl group, which is a carbon double bonded to an oxygen, and an OH group. The carboxyl group gives the molecule an acidic property. The rest of the molecule consists of carbon atoms lined with hydrogen atoms, which is referred to as a hydrocarbon chain. Here's a 3D representation of the molecule. Fatty acids vary in the length of their carbon chain. They can be short, 2 to 6 carbons, medium, 8 to 14 carbons, long with 16 or 18 carbons, or very long with 20 or more than 20 carbons. You can notice that fatty acids always contain an even number of carbons. That's because fatty acids are synthesized in plants by adding 2 carbons at a time to an existing fatty acid chain. Another difference in fatty acids is the types of bonds between carbon atoms. carbon can form either a single bond or double bond with itself. If all of the bonds are single bonds, the fatty acid is called saturated because each carbon atom is connected to 4 other atoms. That's the maximum number of atoms that a carbon atom can hold. Coconut oils are rich in medium chain length saturated fatty acids, such as lauric acid containing 12 carbons. Palm oils are rich in palmitic acid with 16 carbons. Cocoa butter and shea butter are abundant in stearic acid, which are 18 carbons. These fats, with large proportions of saturated fatty acids, tend to be solid at room temperature. That's because saturated fatty acids are quite straight in shape. This linear shape allows them to pack tightly with their neighbors, which allows for strong interactions between molecules, so the melting points of saturated fatty acids are relatively high, making them solid at room temperature. Another important feature of saturated fatty acid is that the melting point of the fatty acid is affected by the chain length. The longer the hydrocarbon chain is, the higher the melting point, the more solid it tends to be at room temperature. If some of the bonds between carbon atoms in the fatty acid tail are double bonds, then the fatty acid is called unsaturated. A monounsaturated fatty acid has only one carbon-carbon double bond. Oleic acid contains 18 carbons, but one of the bonds in that molecule is a double bond. A polyunsaturated fatty acid has 2 or more carbon-carbon double bonds. Linoleic acid has 18 carbons with 2 double bonds. Linolenic acid has 18 carbons with 3 double bonds. But how do we describe the position of the double bonds? One way is to use the omega numbering system. Here's how it works. The first carbon is on the end of the hydrocarbon chain. Then counting inwards 3 carbons, we get the first double bond located in linolenic acid. Linolenic acid is described as an omega-3 fatty acid. Let's go back to linoleic acid. How do we apply the omega numbering system to this one? Well, it is an omega-6 fatty acid, because the first double bond occurs at the carbon number 6. The omega-3 and omega-6 fatty acids are considered essential because our body cannot make them. You probably have noticed that the double bonds between carbon atoms can cause the shape of the fatty acids to change. The double bonds introduce kinks in the carbon chain. The kinks prevent the molecules from packing into a regular structure. The weak interactions between molecules lower the melting point, so unsaturated fatty acids tend to be liquid at room temperature. You can see that unsaturated fatty acids have much lower melting points than saturated fatty acids. Now that you know different types of fatty acids, let's take a look at the fatty acid profiles of several common plant fats and oils. All of them are composed of a mixture of saturated, monounsaturated, and polyunsaturated fatty acids. Saturated fatty acids are found in high proportions in coconut oils and palm oils. They are solid or semi-solid at room temperature and are considered fats. Most vegetable oils are high in monounsaturated or polyunsaturated fatty acids, but low in saturated fatty acids. Olive, canola, sunflower, and peanut oils are high in monounsaturated fatty acids. Soybean and corn oils contain a large proportions of polyunsaturated fatty acids. Vegetable oils can be converted from liquids to solids by a process called hydrogenation, which is used by food manufacturers to make margarines and shortenings. During hydrogenation, the double bonds open, and the hydrogen atoms are added to the carbon atoms. Fully hydrogenated fatty acids will become saturated fatty acids. But margarine never gets fully hydrogenated because that's too hard to spread. Instead, the hydrogenation process goes partially to completion so that the product can be soft enough to be spreadable and melt in your mouth. In this process, hydrogen atoms are added to some, but not all of the unsaturated bonds. Partial hydrogenation causes a problem. The hydrogens flop from the same side of the double bond, which we call cis orientation, to the opposite side, which we call trans orientation. If the hydrogens are on the opposite sides of the double bond, then the molecule has no kinks, and it is straight. That's what we call trans fatty acids. They are actually specific types of unsaturated fatty acids. Let's compare a trans unsaturated fatty acid with a cis unsaturated fatty acid and a saturated fatty acid. Allylic acid is a common trans unsaturated fatty acid with 18 carbons and 1 double bond. Allylic acid and oleic acid have the same molecular formula. Both of them have 18 carbons with 1 double bond in the same location, but they have different structures and properties. You can see that allylic acid in the middle looks a lot more like the saturated fatty acid stearic acid on the left. The linear shape allows the trans fatty acid to pack together quite closely and have a melting point much higher than its cis isomer oleic acid, which has a bent structure. Most naturally occurring unsaturated fatty acids contain the double bonds in the cis orientation with kinks. Artificial trans fatty acids are added to foods to improve taste and increase shelf life. Unfortunately, trans fatty acids are associated with many diseases, so beware of the trans fatty acids in processed foods, especially the ones that list partially hydrogenated oils in the ingredients. Some plants can produce unusual fatty acids in their seed oils. Castor oil comes from the seeds of the castor beans. Castor oil is not edible, but it has many uses in medicine, biodiesel, lubricants, and polymer materials. The major component in castor oil is a hydroxy fatty acid called ricinoleic acid. It has a double bond and a hydroxyl group, which contains an oxygen atom bonded to a hydrogen atom. The presence of this hydroxyl group provides additional functionality for making biodegradable polymers. Another unusual fatty acid is an epoxy fatty acid. Vernolic acid is an epoxy fatty acid that is found in a plant called ironweed. You can see that vernolic acid has a double bond and an additional epoxy group, which looks like a triangle formed by 2 carbon atoms and 1 oxygen atom. This epoxy group makes vernolic acid a useful building block for plasticizers, adhesives, and coating materials. Besides hydroxy and epoxy fatty acids, there are many more types of fatty acids that are made by plants. Now, a quick summary of what we covered in this video. Plants can make various kinds of fats and oils which exist in the form of triacylglycerol, or TAG. A TAG can contain a mixture of different types of fatty acid tails. Fatty acids vary in the length of their carbon chain and in the degree of saturation. Saturated fatty acids have all single bonds between carbon atoms, monounsaturated fatty acids have one carbon-carbon double bond. Polyunsaturated fatty acids have two or more carbon-carbon double bonds. Plant oils are rich in unsaturated fatty acids, and they are usually cis fatty acids, meaning the two hydrogen atoms are on the same side of the double bond. The cis orientation creates kinks in the fatty acid, making them liquid at room temperature. A trans fatty acid has two hydrogen atoms on the opposite side of the double bond, and it doesn't have a band structure. Trans fatty acids are formed when liquid oils are converted into solid fats through partial hydrogenation. Some plants can make unusual fatty acids in their seed oils that have many industrial applications. So as you eat or use plant fats and oils next time, take a moment to appreciate the various types of molecules that plants offer to us.